So we're going to start a new unit now on transformations. And this is something that you've actually done before. A transformation is basically a mapping of points onto another set of points. And you did this in your algebra class. If you remember back in algebra, you might have a problem that said y equals x squared. And you did a graph of that that looked something like that. And then your algebra teacher said, well, what does y equal x squared plus 2 look like? And you learned that that meant that it moves the graph up 2 positions. Well, that's a transformation. You mapped all of these points up 2 positions to get a new graph. So that's how it looks in algebra. We're going to look at that in geometry terms. So in geometry terms, we might have a figure like this, and we're going to map it around. So maybe we translate it like you just did that one. Maybe we take this figure and we move it up. So when I translate this figure, let's see if I can get this to happen here. I can translate this figure up the graph. So that's a translation, okay? And we're going to learn how to do that kind of translations too. That's one we're going to look at. We could also take this figure and rotate it. I could choose a point and say, hey, let's spin it around that point. And I could spin this figure around. So that's a rotation, okay? So that's rotating it around in one direction. We could even take that thing, we could rotate it around some other point. I could take a point out here and rotate it around that point. So it ends up over here somewhere, okay? The first one that we're really going to look at, though, is reflections, where I might take a line. Let's take a line here, and I'm going to take this figure and reflect it over the line. In this case, the line is touching the figure, so it might look something like that. And that's what we're going to deal with in our first unit, is reflections. So again, that's taking every one of these points, every corner point, every point along here, every point on the inside, and mapping it to another point. So that's what transformations do. And there are two basic types of transformations. There's rigid and non-rigid. Rigid transformations keep all lengths and angles congruent. In other words, rigid transformations will map to a congruent figure. If you remember in our review for the last test, it talked about that congruent figures were mapped using rigid or isometric transformations. That's what this is, okay? It's a mapping that creates congruent figures. Non-rigid transformations change the size. So something gets bigger or something gets smaller. That would be a non-rigid transformation. And we'll talk about that kind of transformation as well. We only deal with one of those. We deal with 3 rigids and 1 non-rigid in this course. Now, the rigid transformations also go by another name called isometries. Okay, so isometries are rigid transformations. It's just another fancy name. And isometries, basically, it's a transformation. By definition, it says transformation that preserves distance and angle. Okay, so it preserves the lengths of the sides, it preserves the angles. If we put this in layman's terms, in a very simple case, we could say it has the same size and shape. In other words, it's going to map to a congruent figure. Now, that's our 2 types of transformations. There are 2 types of isometries. There's direct and opposite. A direct isometry keeps the same orientation. Okay, for example, let's go back to our little picture of some things. What that means is that, let's say we did the translation. So I moved this up here. Notice that it didn't spin around. If this is A, B, C, D, this is now A prime, B prime, C prime, and D prime, okay? It didn't change. It's still named in the same way. But if I take it and flip it over, let's see. Let's rename my pieces here. I'm naming this off to the side, but that's okay. You'll get the drift. So when I take this thing and flip it over, now if I name this A, B, D, C, going in that direction, so that's counterclockwise, when I match the letters up, A, B, D, C, well, this time, A, B, D, C, now I'm going in a different direction. I'm reading clockwise. So I changed the direction I read it in. It flipped over. That's what we call an opposite isometry, okay? So an opposite isometry changes the orientation. We could say it flips it. So it flips how it's labeled, okay? So those are different types of transformations. And really what we focus a lot on are these isometries. This is a word I really want you to commit to memory. Commit the term isometry to memory, okay? That's going to be one that we're going to see a lot of. Okay, well, quick little bit, and then we're going to take a look at our first transformation, okay?